Hello students, so we are came here with a new topic for class 12th student in physics, which is electric charges. So what is electric charge? We just saw things in few manner like electrostatic is a what? Electrostatics deal with the study of phenomena associated with the electric charge when the charges are in the rest. Like the Greek first noticed electric charge by rubbing ember with the fur. The Greek word for ember is electron. You might be observed some these cases. For example, like this. This is a small experiment when we are just taking the piece of paper and we saw that the piece of paper attracted by this comb. This balloon experiment. So what exactly is happening in all these cases? The answer is we get in this particular video that how it will be happen, why the case will be happen for here. So if we are just taking a body which is holding the charges on its surface, so these are not in the motion but is stationary on the surface. So we are saying this charge is in a static position. So we are study here, the study of charges is called as a static electricity or electrostatics. Now, we have a copper wire which will have a negative terminal as well as a positive terminal. So, electron start to move from negative charges to the positive side. So, these charges are in the motion. So, the study of a charge which is in motion, we are saying as a dynamics, which we are studying in the chapter current electricity. So these the difference between electrostatics and current electricity basically. So when the charges are in the stationary or in the rest or when the charges are in the motion, when the charges are in the stationary or rest, we are saying this will be electrostatics. And when the charges are in the motion, we are saying as a current electricity. So concept of a charge we will see here one by one. Firstly, what is charge? If we go through the definition of the charge, so it is a physical property of a matter that causes it experience a force when close to another electrically charged matter. Like if this will be an electron, consider this will be a positive charge. Okay, this will be a negative charge. So they will what they will do? There will be force of attraction occurring. But if they have a positive charge and they another have a positive charge also, so they will feel force of a repulsion. What does mean? If we are just taking different kind of different polarity of a charges, simple I mean that if we are just taking opposite charges, so there will be force of attraction occurring, and if we are just taking force of a repulsion for the case, so the charges will be opposite in that particular scenario. So is the force due to the property that is called charges. So this force, what kind of force? This electric force is due to the property of electric charge. Charges are classified in positive charge and negative charges. Proton is said to have a positive charge, whereas electron is said to have a negative charge. If I'm just talking about the magnitude of a positive or negative charge, only the magnitude, so the charge containing 1.6 10 to the power minus 19 coulomb. And the charge is an scalar quantity. If we go through the properties of a charges, because we studied the charges definition, we studied that how charge behave. So, charges like mass. Okay, like mass is a fundamental property or intrinsic property of a matter. Similarly, charge also. But there is a small difference between the mass and charge. Charge carrying by a proton is positive and carried by an electron is a negative. Unlike charges attract each other and like charges repel each other. So I just want to elaborate more here. What is the mean of like charges and unlike charges? So the mean of like charges, that means same polarity of a charges. Unlike charges means they have a different polarity of a charges. That means positive, negative. We can take as a positive, negative, negative or positive. Simply we can take here positive, positive and negative, negative. These are like charges. Like this. So as you can see in the starting two diagram, they both are repel each other. In the last diagram, as you can see, they both wants to attract each other. Another property, if I am moving ahead, so the force between the charge carrying or this will be varies at the inverse square of their separation. Means if the force will be wants to change, so it will be changes if the distance between both the charges are changing. Electric charge is always conserved in the nature. Electric charge is a quantized also. Electric charge is an additive, that is a total charge in the algebraic sum of the individual charges. Electric charge is invariant as it does not depend upon the motion of the charged body or the observer mathematically. Like if the charge in the rest is equal to the charge in the motion. Charge distribution depends on the shape of the conductor. Now firstly we understand how actually the charges are changed by their nature as a charge density. So the charge density is a maximum at the sharply curved surfaces, then flat surfaces. Like this. We have a insulating stands and there will be a charge sheet or charge conductors. So this is a spherical conductor, as you can say. The another one is a pearl shaped conductor. Okay. So in this spherical conductor, as I think you will saw that there will be a spherical distribution. That means the distribution will be uniform. Okay. And but in the shape of a pearl shape, as you can say, where the surface will be the curved, okay, at this sharp. So there will be more density. There will be more density. So keep in mind during solving the numerical, these things are very important. At the sharp edges, the collection of the charges is a more as a rather than the flat surfaces as a spherical conductor is. So like there will be MCQ question which we are moving ahead. What is the mean of actually the MCQ is here. We just revise this chapter, okay, in a quick way. So charges attract each other. There will be few options are there. Which charges are attract each other? Unlike, like, neutral, similar. Very good. Your answer is correct. That unlike charges are attract each other. Moving ahead with the next question. Charges are repel each other. Unlike charges, like charges, dissimilar charges, both A and C. So the correct answer for this question is that like charges repel each other. The third question we have, current density is dash at sharply curved surface, then flat surface, minimum, same, maximum or zero. The correct answer for this question is a maximum. Now, we are just moving ahead with the basic properties of electric charges. The first one is, we have seen that there will be a two types of charges which we are namely as a positive and negative. So we are going to head like they have a tendency to do cancel out each other also. If the size of the charged body is very small as compared to the distance between them, so we treat it as a point charge. Now, all the charge content of the body is assumed to be concentrated at one point on the space. Additivity of charges. What is the meaning of additivity of charges? So if the system contains 2-point charges, let's say Q1 and Q2, the total charge of the system is obtained simply by adding algebraically. Like a Q1, Q2 we have, Okay, so when we take the charges and up like a real number, or they have a scalar like a mass number of the body, so they will be add algebraically. Like if the system contains n charges q1, q2, q3 up to qn, then the total charge will be q net is equals to q1 plus q2 plus q3 up to qn, where the charges will be given. Charges has a magnitude but no direction, similar to the mass. However, there is a difference between the mass and charge. So, mass of the body always positive, where charge can either positive or negative. Proper sign we have used while adding the charges in a system is an important role playing. For example, we have a total charge of the system containing 5 charges, or all the 5 charges are at the positively charged. So we are adding like these charges like 1 plus 2 plus 3 plus 4 and plus 5. So the algebraic sum will be the 15 in the same as a unit also. Next is the quantization of the charges. So experimentally, it is established that all free charges are integral multiple of the basic charge that is denoted by E. What it's mean? Like we have a conductor and we want to transfer this. They have some charges also, and we just want to transfer this charge from one body to another body. So we can transfer like what? Like one charge will be can move through in this particular body. Then another charge will be start to move in this particular body. So one by one we are transferring this charge, not half portion. Okay. So first time if we send the charge like total charge will be Q. So we just send one charge. Next time two charges like E plus E, two charges. Third time, if we are sending 3 electrons or 3 positrons, clear? So like these type of things in the whole numbers form, integers form, not in the fractional form. So these are called as a quantization of a charge. Like we have the charge Q on the body or the system is given by Q is equals to plus minus N. Integers are like positive and negative also. So charge have a both nature, positive and negative. That's why we have taken the word integer. Like as we saw where n is a positive integer, so positive or negative, they both can be have in the case of integer. The basic unit of the charge is the charge that proton or electrons that which will be carrying. Like electron, if I'm just talking about, so electron have a charge negative, and if just talking about the positive charge, so they have a positive charge. Like a proton, they have a plus E. The main fact that electric charge is always integral multiple of E terms as a quantization of electrons or the charges. There are large number of situations in the physics where certain physical quantities are quantized. Okay. If you're just saying what is a quantized other, so we have another term like a parity. In the quantum mechanics, we have a term parity, which is also quantized. In quantum mechanics, each and every things are quantized. Okay. The next thing we have a quantization of a charge was first suggested by experimental laws, which was done by English experimentalist Faraday. He is a very famous scientist for who gave the most important few experiments in the physics, which we studied in this class 12th also. It was experimentally demonstrated by Millikan in 1912. So there will be experiment, Millikan oil drop experiment, by which we saw this particular things. In the international system, SI system, a unit of a charge is called as a coulomb, and it is denoted as a capital C also. 1 coulomb is defined as a unit in terms of electric current. Like in terms of the definition of a 1 coulomb, the charge flowing through one wire is a 1 ampere. In the system, the value of the basic unit of a charge is E is equals to 1.6. 6.02 10 to the power minus 19 coulomb. So this is a universal constant. Let's say E is, if I'm just talking, this E is a universal constant. This value will be not changed. Now, there will be an about values like E will be, we know, 1.602 10 to the power minus 19. If we just put this value in this equation, n is equals to Q by E, we get the value of n, which is 6 10 to the power 18. Means in 1 coulomb, we have 6 10 to the power 18 electrons. In electrostatics, charges of large magnitude are seldom countered, and hence we are a smaller unit is a 1 microcoulomb. Or 1 millicoulomb, which is a 10 to the power minus 3 coulomb. If the proton and electrons are only the basic charges in the universe, all the observable charges have the integral multiple of electrons. Thus, if the body contains n1 electrons and n2 protons, the total amount of a charge of the nucleus which we are saying, atom which we are saying, that is n2 times E plus n1 times minus E, which is n2 minus n1 times E. This is the total charge of the body containing in the form of a positive and negative both. Since n1 and n2 are integers, there are difference in the also integers. Like n1 may be differ, n1 may be 2 or 3, like this. Clear? So maybe n1 and n2 are same, may not be same, but they most important things are there that they both have an integer. Thus, the charge on the body is always integral multiple of E and can be increased also the steps of E. The step size of E. What is the meaning of a step size? Firstly, I just want to elaborate. See, step size mean if we just want to send out the charge, transfer the charge. So there will be some levels. So if we just want to transfer or relocate the charges, so there will be few steps are there, and if the steps are E, however very small, so because of the microscopic level, we are dealing few microcoulombs, okay, in it. Or we can take millicoulombs also. At this scale, the fact of that charges can increase or decrease in the units of E may not be visible. So, if we are just taking another thing that the granular nature of the charge is lost and it appears to be continuous also. Like this situation is can compared with the geometrical concept of a point and lines. A dotted lines views from the distance appears continuous to us but is not continuous in reality. Okay, as many points very close to each other normally give an impression of a continuous line. Many small charges taken together appear as a continuous charge distribution, but they are not continuous actually. At the microscopic level, one deals with charges that are enormous compared to the magnitude of E. Since E is equals to 1.6 10 to the power 19 coulomb minus, and a charge who have a containing this magnitude saying as a 1 microcoulomb contains something like 10 to the power 13 times of electronic charge. How this will be gained? So we know this value of E. So the value of E 1.6 10 to the power minus 19 coulomb. If we just want to convert into the micro, so 1.6 10 to the power, we just eliminate in two factors like 10 to the power minus 6 and 10 to the power minus 13 microcoulomb. Okay, so if we just talking about the 1 microcoulomb, how many charge containing? So N is equals to Q by E. And if I'm just talking about 1 microcoulomb, 10 to the power minus 6. Electron we know 1.6 10 to the power minus 19. So if these factor I'm just taking in the upward direction, upside, so the value which we'll receive, that is approximately 10 to the power plus 30. That's why this value came here in the nation. At this scale, the fact of the charge can increase or decrease only in the unit of E. May not different varies, or we can say that charge can taken as a continuous value also. Thus, at the microscopic level, the quantization of a charges had no partial sequence and can be ignored also. At the microscopic level, where the charges involved are in the order of a few tens of or hundred of electrons, that's why they can be counted. They can be appears in discrete lumps, and quantization of a charge cannot be ignored basically. It is a scale involved that is very important, which is a conservation of a charge. So what is the law of conservation of charge? The law of conservation of a charge defines that or states that for an isolated system. So that means for an isolated system, the charge cannot be created, cannot be destroyed. Means charge never be create, neither be destroy we can do. That means isolated system, electric charge remains constant. Again, in the law of conservation of a charge, this will be states that if the charge are in the isolated system, charge can neither be created nor be destroyed. Simple. We have two types of basically conductor. After in contact, we get this value. Few charges are exactly transferred. So the mean of that, they will transfer their charges when the charges are in the equal. Charges continuously transferring one body to another body, when the total amount the charges are must be in the equal condition, they will not gain. चार्जेस तब तक मूव करते रहेंगे जब तक दोनों पर इक्वल अमाउंट का चार्ज नहीं आ जाता. Okay, so the charge are transferred from B to object A, but the total charge always be the constant for the system. If I'm just taking another example for the glass, so glass rod, if just rubbed with the silk, so becomes positive because it loops some electron, and the silk become negative because the amount they will gain of electron which is lost by the glass. The isolated system of a glass rod and silk is a neutral. In the pair production or pair annihilation of a charges also conserved. Like this process of a gamma ray transform into the electron and positron. Gamma rays breaks into the two, one like a one is a proton, one is a electron. So in the nuclear reaction, charge is a conserved. For example, like this. If we just want to disintegrate that particular uranium particle, that disintegration containing the number of a proton and number of a neutron in equal amount, as well as the number of electrons also. Here the initial charge is a 92 plus 0. As you can see here, this is a 92, this is a 0, and at the final, if you just count it down, so the final charge will be also 54 plus 38 plus 0, that is a 92. So charges are always conserved, means constant, they will not vary. So move with ahead, some questions which is a numerical part of the MCQ. So the law of conservation of an electric charge states that for an isolated system, the net electric charge increase, decrease, remains constant, becomes 0. So the correct answer for this question is it remains constant. Conservation of electric charge states that अगर चार्ज आपका सिस्टम जो आपने लिया है दैट विल बी आइसोलेटेड, तो जो आपका नेट चार्ज होगा वो हमेशा सेम रहेगा, दैट रिमेन्स विल बी द कांस्टेंट. Next question we have, when a glass rod is rubbed with the silk becomes positive because it loses some electron and the silk becomes dash by an amount which is gaining some electron. Positive, negative, zero, neutral. Very good. Your answer is correct. That is a negative. Electrification. So what it's mean? See, classification of a material, we know that classification of material based on the some electrical properties of material are classified in three basically ways, like conductor, insulator and semiconductors. If I am just talking about the conductor, clear? So a conductor is a material through which charges can flow easily. जिसमें चार्जेस फ्लो कर जाते हैं आराम से, वो हमारा क्या हो जाता है, कंडक्टर हो जाते हैं. जिसमें चार्ज नहीं फ्लो करते वो हमारा क्या हो जाता है, इंसुलेटर हो जाता है. ठीक है बच्चों. सो एग्जांपल्स, मोस्ट metals are good conductor. Okay, this will be saying as a charge conductor. Insulator. Insulator is a material through which charge flow poorly or not at all. कुछ ऐसे भी मटेरियल्स होते हैं जिनमें चार्जेस हमारे फ्लो ही नहीं कर पाते, दैट विल बी कॉल्ड एज इंसुलेटर. फॉर एग्जांपल सिल्क एंड कॉटन थ्रेड, rubber and many plastics are good insulators because they can't transfer their charges. So charged insulator for this case. Semiconductors. So electrical properties of a semiconductor lies between the conductors and insulator. For example, like germanium, silicon, gallium, arsenic, etc. These are the semiconductors. Electrification. So the method of imparting charges on the surface of the body is called electrification. Method of electrification, like how we will do the electrification. So charging by friction, charging by conduction or charging by induction. These three methods are we have. Method of a charging, firstly we will look charging by friction. So we have a glass rod, we have a silk cloth. We just rub both the things and the electrons start to remove from that. So when the electron losses, positively charged have a glass gain, and when the electrons comes with a silk rod or silk cloth, so they gains the electrons. That means negatively charged. This process of a charging we called as a charging by friction. Now charging by induction. If we just take in two particular metal ball, one is charged, another is a not charged. So when they will brought closer to each other, what will be happen? This will be a neutral body. So how this will be a neutral? Because they have a number of positive is equals to number of negative charges, by which they attract their negative charges. As I told, the neutral body becomes neutral because they have a number of a positive equals to number of a negative. So negative will be attracted by the positive charge. Okay, and other one will be transferred by the earth if we just connect by the surface by the earth. This process is called as charging by induction. Moving ahead, method of a charging is a good conductor, charging by conduction. So we have a conducting charged material, we have an uncharged material also. When they will touch the uncharged object, equal number of charge distribution occur. That means the charge are charged get equally charge distribution on the uncharged object as it is touched. This property or this process is called as a charging by induction. Let's start with some MCQ question so that we can understand that what we early study that we have understood or not. When a glass rod is rubbed with a silk rod, the glass rod loses electron and the silk rod equally gain amount of electrons. This process is called charging by induction, charging by friction, charging by conduction, or charging by electricity. The correct answer is charging by friction. Moving ahead with the next question. When a charged object is touched to another uncharged object, then the charge from charged object get equally distributed on the uncharged object. This process is called as charging by induction, charging by friction, charging by conduction, or charging by electricity. Your answer is correct, that is the charging by conduction. Third question we have, when a positively charged body is brought close to another uncharged body, that is a negative charge of an uncharged body get accumulated on the same side on the charged body. This process is called as charging by induction, charging by friction, charging by conduction, or charging by electricity. So your answer is correct, that is charging by induction. So this is all for today's class. Hope you enjoy the class. Let's wait for the next class. Thank you so much till here. Take care.